Sorry guys, actually sir was disconnected in the middle because of some internet and network issue. I'm going to reintroduce sir and then we're going to start off with the session again. So again, Priyanka here, moderator of the session and your host, and we welcome you all for the masterclass, which is on 32-bit embedded system. So it is our pleasure to have Mr. Sumit Mohanty from HCL as an IoT and embedded system specialist. Sir has been working with a couple of colleges in past, which is ITM University Gwalior and CMR Institute of Technology as an assistant professor. Currently, Mr. Mohanty is embedded system and IoT trainer in HCL and will be enlightening us today with introducing the topic of 32-bit embedded system. So we are very excited to start off. The session is all yours. Please take it over now.
So hello everyone. I hope my voice is audible to all of you. Yeah, fine. Okay. So I'll just, I hope my screen is also visible to everyone. So what we will be starting today is, as you all are here gathered to understand and to know or to elevate your knowledge related to embedded system. Okay. So before starting, just let me know if by chance something somewhere it is missing or somewhere voice is missing or something happens in between, some interrupt happens in between. Please let me know because I am not able to see the chat screen. So please unmute and let me know or let Priyanka ma'am know if there is some issue so that we can again repeat that same concept or we can just again repeat that particular concept. Okay. So what we are going to start now is related to embedded system. Okay, so first we will try to understand what is an embedded system. I guess most of you are from the circuit branches like electronics or electrical, or maybe if you are from computer science. So just I'll go to the chat window, or if you can unmute or go to the chat window. I just want to know whether anyone is there from computer science background or all are from the circuit branches like electrical or electronics or instrumentation, something like that. Is there anyone from computer science background? Okay, few are okay. Great, great. Okay, that means few are there from the computer science background. Okay, so what we are going to understand is that what is an embedded system, okay, and how it is different from the regular system or the computer which we are using, and then what is the use of processor inside it. Then we will gradually understand about what is 8-bit processor, 16-bit processor, 32-bit processors. All these basics will be understanding today. And apart from that, how much ever possible, we'll be seeing how we can see the examples, and we will try to execute some hands-on related to this particular aspect. So first thing is, if can anyone put it in the chat box, what are the embedded systems or any example of embedded system? Any one of you know? Can you just put it in the chat box? Any example of embedded system? Arduino, is also an example. Okay, but that is an high-end example. Okay, any other day-to-day means daily life examples? Yeah, great. One washing machine is an example. Great. Activity tracker is also an example. Smart refrigerators are also an example. Smart remotes are also an example. Great. Great. So if I tell micro ovens are there, that is also an example. So these are variety of things which are example of embedded system. So if I try to find out the difference between how does in a laptop works or your PC works, and how does your washing machine or a microwave oven works. So what is the basic difference we can find? Is there any difference of working of your laptop and also your washing machine or your microwave? Okay, so from there we can understand the concept of embedded system. Okay, so basically in your laptop or your PC you have a processor. Okay, mostly it's a 32-bit processor. Intel you have mostly. Okay, or you have a 64-bit processor. Nowadays, all the systems are having mostly 64-bit processors. Okay, so now what is extra which we are doing in laptop, which we are not able to do in washing machine or microwave, and what we are doing in microwave or washing machine, which are not able to do in laptop. Okay, these are completely two different aspects of what do you call processor based systems. Okay, so laptop is basically only processor based systems, okay, which has a processor which can take some input, which can give us some output, okay, on the screen. Okay, we have different calculation probabilities. We can calculate so much, we can take so much of data, we have n number of possibilities. Okay, but when we discuss about a microwave oven, or let us say an washing machine, there what happens, there is no scope of doing n number of things. Microwave oven is dedicated to some particular things, washing machine is dedicated to a particular thing, or a smart refrigerator is dedicated to particular things. So you have dedicated things. When you want to do, you require the embedded system. Otherwise, if you have just n number of possibilities of things you need to do, you need to do calculation, you need to do machine learning, you need to do what do you call basic what do you call probabilities, calculations, writing, and all these things. So variety of works you want to do, you want to work on higher value of numbers, that time you need the processor only. That's how your laptop or your PC works. And because there is a dedicated work is there, that is how it becomes an embedded system. Which one? Your washing machine, the microwave oven, smart refrigerators, MP3 player, all these things. Okay, now then you will say, sir, okay, if my laptop can do n number of works, then I will prefer that. Why I will prefer my microwave oven? But what is the problem your laptop has? The problem it has is, if let us say today I'm opening my Word file, okay, one of the Word file I'm opening, okay. After 3 days, I'm opening my Word file. After 1 month, I'm opening the N Word file. After 1 year, I'm opening the same Word file in the same system. Okay, whereas I may be doing in background some other different works. So can you guarantee that if in the first time when you are opening the Word file, it will open in 1 second, let us say, then every time when you open the Word file, it will open in 1 second? Can you just guarantee it? Yes or no? Can you just put it in the chat box? Okay, great. Most of you are actually fascinated with smartwatches and fitness trackers. Okay. Voice, is it audible now? Or is it not audible only for Sandhya? Is it audible? Okay. Okay. So as I can see, many of you are actually interested with lots of smartwatches, fitness trackers, and all these things. Okay. So even if fitness trackers and all these things, there what happens? So one major impact of embedded system is the time boundedness. Okay, so time boundedness means, if in a microwave, if you are heating it for 1 minute, does it, so if whether it is today, whether it is after 1 month, whether it is after 1 year, if it is working, means if you put 1 minute, means will it heat you more than 1 second or 1 minute? No. Washing machine, if you are washing it for 30 minutes, means it will wash you for 30 minutes only. It will not wash you for more than 30 minutes. I hope this concept is understood for everyone. Boundedness of time. Someone has some issue. Someone was raising the hand. Yes, response time will change if it is only a processor. If it is your laptop, if it is your PC, but 99% of embedded systems are designed in such a way that the response time will not vary. It may not be a fastest machine, but it will be an accurate and reliable machine. I hope all of you understand. If I tell accurate and reliable, I guess it is understood for everyone. Accurate means if I do it is almost, when I'm telling it as 1 second, it will do it in 1 second. Okay, reliable means 100 number of times also if I put it for 1 second, it will always work for 1 second only. Understood? So embedded systems more emphasize on the reliability, on the timings. I hope this concept is understood for everyone. Okay, first thing, they are into some dedicated task. Second thing is they are into, or they are highly reliable. They may not be fastest. The same generation of delay, the laptop can do faster, but the response time for laptop varies based upon the background task. Whereas if you go about washing machine, about refrigerator, about microwave oven, so there what happens is the response time almost remains same. That is how it is more reliable. Okay, now come to the technical part. Okay, the technicalities of embedded system, like many of you have already put it in the chat box. Okay, so embedded system means basically you have a specific hardware which is designed to solve a particular task. Inside that, a software is embedded. That is how it is, the word comes as embedded. I hope the concept is understood. The two important thing is, one is dedicated task, second is reliability. Okay, and the third important thing is there should be some hardware to solve the dedicated task, and it should be solved by a software. So basically what happens is, when we work in embedded system, there is some word called as software, which actually we all feel that it's such a big thing, software. Okay, but software is nothing but actually what the coder or a developer writes the code. When you have a dedicated hardware, it definitely has some processor. So processor takes the code and accordingly it works. Okay, so the code which we give to the processor, that is actually nothing but the software which is put into the hardware, so that your embedded system is able to solve your dedicated task. I hope this concept is understood for everyone. What is embedded system, what is software, what is hardware? Okay, so now don't feel that it is so much complicated to design a software. Designing a software means nothing but writing a code so that the hardware can behave according to the code which you have written. That's it. That is a software. So already we have discussed. So what are the different embedded system examples? What is an embedded system? What are the basic two purpose? Okay, and what happens? We can use it for larger devices also. We can use it for smaller devices also. We can use it in robots. We can use it in MP3 player. We can use it in fitness trackers. We can use it in microwave ovens. So there are various way in which we can use it. Okay, but the only thing is there should be a dedicated hardware which obeys the software what the programmer writes. I hope it is clear. Any issues, I'll just check the chat box. Okay, okay, fine. So as we are discussing various examples, we have GPS system, charging stations. Nowadays, electric vehicles are there. So there is a major application of embedded system, ATMs, fitness trackers, automotive systems. Any automotive system definitely is an embedded system. Various medical devices. These are all examples of embedded system. Okay, so what are the importance? As I told you, so first thing, as I told you, is the real time responsiveness. Okay, so there must be a reliability of responsiveness. If first time it is responding in 1 second, every time it should respond it should respond in 1 second. Okay, it should be solving some specific task. And then the additional features which is required is, one is low power consumption. Okay, that is it should work with a, because the actual work itself requires so much of energy. Let us say consider an electric vehicle. So the actual electric vehicle, for running it, takes so much of energy, so we cannot divert again more energy into the embedded system. Are you getting my point? So that is how it requires a low power consumption. it requires some connectivity. Connectivity means it should have some medium of communicating with the other devices. The medium may be a wired way of communication, maybe wireless way of communication. Okay, can be directly by wired, can be without wire, with IoT, with Bluetooth, any of the ways can be there. Like Arduino, you told, like Arduino prepares another type of controller, that is ESP. So ESP has ESP32. If you, I think all of you have heard about that. ESP32 has both Bluetooth and Wi-Fi connectivity with it. That also has a processor inside it. Okay, they should have minimum cost and minimum space. Okay, if the space for the embedded system becomes more, then it is not suitable to put it in the actual system. Okay, and it should be, as I told you, reliable and should be secured. Secured means, that means all or the unauthorized person should not be able to access that. Okay, so these are the importance of your embedded system. Okay, so now, just before going to the programming part, so we will just try to understand what is a basic embedded system. Okay, and how does it works. Okay, so I will just present, I think I'll present a white screen. Let me know if it is visible to everyone or not. Is it visible to everyone, this white screen? Okay, okay, fine. So basically, when I tell there is an embedded system, okay, what I need to understand is what is the basic construction of an embedded system. Okay, I can just change it here. So let us say I want to understand. We will first understand what are the important components of an embedded system. Okay, like someone told Arduino. So Arduino is an embedded system, correct? Okay, but what are the important component it has? Anyone can tell. So let us say this is a complete embedded system. Clear? Okay. Now, what should be the minimum components inside this? Any one of you? Can you put it in the chat box? One by one, if you can tell, we will write it over here. Okay. So basically what you are telling a processor, in what we do is, instead of that, we put something called as microcontroller. I hope all of you have heard about this particular word. Okay. The heart of the embedded system is a microcontroller. Have you all heard about this? Okay, so what happens is, now when you are telling a processor, so processor is one important or the major part of the microcontroller. Are you getting my point? Processor, or we sometimes call it as the core. Is this visible to everyone what I am writing, or it is a CPU? I hope it is visible. Okay, so this is the first major part of a microcontroller. Okay, now what else it has? So you'll ask, sir, why only the processor? Means why the microcontroller? Why not the processor only? Because if you try to understand, processor has what? Processor has the buses, okay, and some ALU. ALU, I hope all of you know what is ALU. Okay, it has its own ALU, let us say. Okay, it has its own buses. Okay, so there are different aspects. It has a barrel shifter. I hope all of you know about this barrel shifter, ALU. It has buses. Okay, it has some specific what you call timers also. Okay, so there are a few things which it has. Yeah, arithmetic logic unit. Okay, so what we will do here is, so in a processor you have all these things, okay, but this is not enough to drive the, and second thing is this bus is not enough to take that much number of data. Timer is not enough to do that much number of calculation. So what we do is, only for calculation part and the delay part we use processor, okay, but what all external things we require, for that we use the, what do you call, the microcontroller, so that it can has different parts. What are the different parts it can has? Microcontroller, it can have a GPIO. Have you heard about this word, GPIO? That is the general purpose input and output. Like if you go for Arduino, in Arduino we have AVR microcontroller. Arduino is not a microcontroller. Normally people misconfuse or get confused that Arduino is a microcontroller. No, Arduino is an embedded system which has a microcontroller, that is AVR microcontroller. Okay, so you have AVR microcontroller in case of Arduino, okay, which has its own processor. Okay, so that we will see little late, but now any other things anyone can tell you about the GPIOS? What is the full form of that? Let me check if anyone has given. Okay, great. Someone has given general purpose input and output. Okay, so this is what this can be. This GPIO can be used as an analog output and digital output, an analog input, digital input. Okay, apart from that, for some other way or medium of transmission also. Clear? So you have GPIOs. Okay, like in Arduino, you have A0 to, like A0 is there only in the normal Arduino Uno. If you go for Arduino Mega, you have A0 to A7. That is the analog input pins. You have D0 to, I think D13 or 14, something like that in Arduino Uno. That is digital input, digital output. So these are all coming under the GPIOs. Okay, then you may have some communication interfaces. Okay, so what are the communication interfaces we can have? You can have an UART. What is UART? That is universal asynchronous receiver and transmitter. That is what? A wired transmitter. Okay, you can have SPI. Okay, that is synchronous transmission. You can have I2C, inter-integrated circuit. Okay, these are all for used for wired transmission. That means the data will be transmitted by wire. Okay, whereas UART is asynchronous transmitted. Okay, asynchronous means just by single wire you can transmit the data. Okay, SPI and I2C, these two are serial peripheral interface and inter-integrated circuit. These two are used for synchronous way of transmission. That means I think all of you have gone through digital electronics. So what happens is, from one place to another place data is transmitted. So there is a data line, and after that there is a clock line. Have you heard about this clock? Okay, so there is this what you call synchronous data transmission. That means there is a synchronization between the two data transmission. Okay, so with every clock pulse one data will be transmitted. I hope it is clear to everyone, the communication protocols which we have. Okay, so now what we will have is, so these are the wired transmission. Okay, now apart from that, what we can have some timers. Okay, other than this we can have some timers. Okay, now we can have some ADCs. Okay, we can have an interrupt controller. IC means interrupt controller. Sometimes interrupt controller is a part of processor. The processor which you are going to discuss today has its own interrupt control. Clear? We can have some DAC. Okay, you can have other different types of communication protocols also. Okay, so basically what happens, so this part is understood. Now what happens to how do the processor connects to these things? This is one important thing. How does the processor connects between these things? The SPI, I2C or GPIO or all these things. So basically by using the buses. You have buses over here to communicate between the processor and the other peripherals. Okay, these are what I means. All these things are actually called as the peripherals. Whether it is GPIO, whether it is UART, SPI, I2C, these are all called as peripherals. Okay, then we have a processor. So processor, how does it connects with the peripherals? By using the buses. There may be address bus, there may be data bus, there may be system bus. So mostly there are three different types of buses are there that we'll be discussing in later in details. Okay, so basically this is the microcontroller, the black one. Okay, now you'll ask, sir, okay, this is the microcontroller. So is the microcontroller itself an embedded system? No. Microcontroller is a microcontroller which has a processor, and apart from that processor, some peripherals inside that. Okay, now so why that is how we are not calling the Arduino as a microcontroller. Arduino is an embedded system because it has a microcontroller. Apart from that microcontroller, we may have some external things in the embedded system. Okay, we can have a motor driver. Okay, we can have some LEDs. We can have some LCDs. Okay, we can have some other displays. Okay, so how does these all communicate with this? Okay, we can have some external sensors. Okay, so how does these all things communicate? So sensors are mostly connected to ADC. Now in few of the microcontroller, you don't have inbuilt ADC. Okay, like if you say 8051 microcontroller, I guess all of you know about that. So if that controller, if you tell that doesn't have an inbuilt ADC. Okay, so in that case, what we do, we have to connect one external ADC to the uh, embedded system or to the microcontroller. Okay, so basically this is the basics of embedded system. These are the important component. I hope the components are understood for everyone. Okay, so in this microcontroller case, we can have different types of microcontrollers. We can have which one, the popular one in the academics, that is the 8051, which we normally see in the colleges. Okay, this is an 8-bit microcontroller. How does this 8-bit is defined? The data bus, how much amount of data we can take, that is defined in the capability of the particular microcontroller. So 8-bit means the data bus is 8-bit. Okay, we can have a PIC, peripheral interrupt controller. Okay, so that is 16-bit. We can have the AVR. This is very popular because this is only used in what do you call the Arduino or your ESP. They all use this one, Alf and Vegard's RISC processor. Okay, so this is available in 8 and 16 bits variant. Okay, so basically what happens in 8051, this is something called as CISC based microcontroller. CISC means complex instruction set. So we will not go much details into it. So just you can understand, CISC means instructions are complicated. Okay, the hardware is simple. But RISC means reduced instruction set. That means the instructions are simpler, whereas the hardware is complicated. So when hardware is complicated, you have the flexibility of doing more number of operations, whereas when hardware is simple, the instruction has to be more and more complicated. So basically, this PIC and AVR, these are your RISC machines. That is reduced instruction set architecture. Okay, so they have almost same size, all the instruction sets. Okay, they have more flexibility because the hardware is complex. Okay, now, so what today we are going to discuss which processor is. So basically, these all microcontrollers has their processors. So if you say about this one 8051, it has its Intel based processor. This Intel based processor is 8-bit processor. That is why this is 8-bit microcontroller. For PIC, there is a processor given by General Electric or General Instruments. This is a company which basically manufactures PIC microcontroller. So that is General Instruments. That is a 16-bit processor. So that is how it is 16-bit microcontroller. For AVR, what happens? The same company itself or develops, and this is the processors which it uses are of Atmel. So that is how you will see Atmega name, you will see Atmega. That is because Atmel manufactures the processor. Okay, now what we are going to discuss is about a 32-bit processor. 2-bit processor. Okay, and this 32-bit processor is nothing but called as ARM. What is ARM? That is advanced RISC machines. Okay, so what is an advanced RISC machines? So that we need to understand. So advanced RISC machines means it takes the flexibility of RISC. That means the hardware is complicated. Okay, the flexibility is there, but it also takes some of the advantages of CISC. That is how it is advanced RISC machines. Okay, so why does 32-bit processors are used? Because so that you can interface more number of devices. Okay, what you can do is you can have more number of what do you call interfaces. Okay, now 32-bit, because it is 32-bit, so what happens is it is more faster and reliable also. Okay, okay. So I hope up to this it is understood for everyone. What is ARM processor? So basically ARM, normally people think that ARM itself is a microcontroller. No. So when we tell about ARM, basically they give the design of the core processor. Okay, they do the design and after that they license it to different microcontroller manufacturing companies. Okay, so what they do is they design some of the core processors. Okay, so what they do is in the design they put uh, buses. Okay, so buses, there is something called as AMBA buses, advanced microcontroller bus architecture. Okay, so there is a system bus, there is a peripheral bus. Okay, so there is ASB, advanced system bus or ARM system bus. Okay, we have ARM what do you call peripheral bus, we have ARM high performance bus. Okay, so this is for high frequency, this is for peripheral, this is inside the processor. Clear? So they license it to the different microcontroller company. Before that, they design the core. So where should be the peripherals? Where should be the buses? Then where should be the interrupt controller? These all things they basically do. Okay. What should be the instruction set? So it supports what do you call 32-bit instruction set, 16-bit instruction set, even 8-bit instruction set. Okay, this 32-bit instruction set is called as ARM instruction set. The 16-bit one is called as thumb instruction set. 8-bit one is called as Jezel instruction set. That means it supports some of the Java-based coding also. Okay, so basically ARM classically what similarly this interrupt controller which we will be using is called as NVIC, nested vectored interrupt controller. Okay, it uses pipelining. In the instruction set it uses pipelining means what? So when you, let us say you have 9 instructions. Okay, so when first instruction set is decoded, like normally what happens is instructions go in 3 different phases. Okay, one is fetch, one is decode, one is execute. Okay, so when the first instruction set is fetched, okay, in the first cycle, now in the second cycle, second clock cycle, what happens? Here goes the second instruction, here goes the first instruction. Now when in the third cycle is there, so here comes the third instruction, here the second instruction, here the first instruction. Okay, so this is how we call it as pipelining. So this is how it is more faster than the other microcontrollers. Okay, so ARM has basically some series. We have ARM 7, ARM 9, and ARM 11 mostly. Okay, so 7 mostly has 3-4 important features to understand. That is called as TDMI. TDMI means T is for thumb instruction set. That means it can support 16-bit instruction set also, which only we will be using. Okay, D is what? There is a debugger, on chip debugger, on chip debugger. That means you can program it and you can check whether your program is executing properly or not. So any mistake is there, you can debug. Someone was asking, so pipeline is because we are using so that it becomes faster. Like what happens is one instruction, if I execute, let us say I have total 3 instructions. Okay, so if one instruction I'm executing, let us say it is taking 3 seconds. Okay, so total if I'm executing 3 total it is taking 9 seconds. Okay, now in this way what happens if this once 3 second I am dividing it into 1 1 and 1. So what happens here is, so let us say first instruction when it finishes it 3 seconds, by that time already the second instruction is executed. Okay, so total if you say in 6 seconds all this will be instructions. So 3 seconds for this, 2 seconds for this, and 1 second for this. So total in 6 seconds your complete instruction or the 3 instructions are already executed, whereas if you don't use pipeline it will take almost 9 seconds to execute. I hope this is clear to everyone. Okay, so now what we will have is, so this is ARM 7. So we have a debugger, we have a multiplier. Okay, I hope it is understood for everyone. Can you all hear me? Okay, similarly there is an Which one? Pipeline? So because, so this is 1 second, 1 second, 1 second, this is executed. Okay. By the time it is 1 second, here it is becoming next 1 second. Okay. Now this here it is coming 1 second. Okay. So again, this here it is coming 1 second. When it reaches here, this comes 1 second. So total 3 second here. By that time, here it takes 2 second. Okay. Here it takes extra 1 second. So 3 plus 2 plus 1. Total 6 seconds. This is for an example, not like exactly it works, but it saves time by working in this particular way. Okay, so ARM 9 has some advanced features. Okay, ARM 11 is also having some advanced features. Now what happens is ARM 7 actually what it does, it is again used with some Cortex series. That means Cortex M4, M3, M0. So that is what happens, some advanced features along with the classic ARM series. These are all called as classic ARM series. Okay, these are all called as Cortex M series. So this is Cortex M series, which is mapped to ARM 7. ARM 9 is mapped to Cortex R series. ARM 11 is mapped to Cortex A series. So this is advanced one with the DSP and all. So many different ways of calculation you can do. This is R mean, this is for real time. You can have an operating system, real-time operating system inside this, just like how we do in our regular laptop or PC, and we can work on it. Okay, so this is how we have. So as I told you now, we have this ARM processor. A little bit in hurry burry, the diagrams are not coming properly. So basically, let us say this is ARM processor, okay, which is actually designed by whom? By the ARM company. Okay, and they have given license to different companies. Now let us say they can give license to ST Microelectronics. They can might give it to Texas Instrument. They might give it to Renesas. They can give it to different microcontroller manufacturer companies. Okay, so what we have an ARM processor. Okay, then what the microcontroller company does, they now prepare two different memories. Okay, what are the two different memories? One is the flash, which is the permanent memory. One is the SRAM, okay, which is the temporary memory. Okay, this flash is otherwise called as code memory. This is otherwise called as data memory. So what happens when we program anything that is stored in the ARM processor by the debugger? Okay, then what happens? This is given to the code memory. Now from the code memory, if there is some data, that is given to the data memory. Okay, now how does it executes? We have bus, system bus. Okay, so what happens is now through this bus, this code what you have written, that data comes to this bus. Then what it does, it comes to the GPIO. For an example, okay, GPIO has some registers. Okay, now based upon this registers, every GPIO port has some pins. For just basic example, I'm telling. More details anyways we cannot finish in this much less time, so we'll just try to understand. So we have a GPIO port, so every GPIO port has some registers. Okay, now those registers can be programmed by the programmer so that these pins can be, or the behavior of the pins can be changed. Similarly, let us say you have ADC. Okay, so ADC also has some registers. Okay, so those registers can be also programmed from the code, which can be taken by the bus and given to the ADC registers. Accordingly, ADC can behave differently. Okay, so we'll just go into the previous slide. So now when we are telling about embedded C programming, why does C programming is required? So that what we can do is the programmer can interact with the registers which are present in the microcontroller. Okay, so we have, that is how we use the embedded C programming. Okay, so in embedded C programming, basically it is same as C programming. I guess most of you are comfortable with that. Is how, like, there is more emphasis on the bitwise operators, on the arrays, strings, on the pointers. Okay, we have more emphasis on that. Okay, so what are the basic embedded C programming things we will be discussing, like data types, variables, operators, control structures? Okay, what are the data types you know in C programming? Any one of you can put in the chat box. Yes, IoT is also embedded based. Even your ESP32 we call, that is also an embedded system. Anyone who can tell what are the data types you know? So have you heard about the integer data type? Integer data type, you have your this one, what do you call, uh, float data type. I'll just check if I can write here. Yeah. So we have integer. Is it visible to everyone? What I'm writing on the PPT? No, no. Can you see it on the PPT? What I'm writing? Okay, great. Okay, so we have integer, we have float, we have character data types. Okay, these are these few of the basic data type. So what happens is this integer data types take, I think, 4 bytes. Now bytes and bits, I guess all of us know what are the difference. Okay, 4 byte, each byte means 8 bits. Okay, so integer, we have float, we have character takes 1 byte. Okay, then we have double. Okay, we have long integer, we have short integer. So there are various different data types are there. Okay, variables are what? Variables can be any name of any data type. Okay, we can write int a, that's a variable. Okay, so variable we can define like this. Later we can assign it some value, like int a is equal to 5. This is also fine. Okay, so these are the various variable which we can assign. Okay, we can write char c is equal to a. We can have like this. Okay, we can have some derived data type variable also, like we can say there are arrays. Okay, so I can write int a. Okay, and we can write 1 2 3 4 5. I hope it is understood. Arrays, I guess all of you know. We can have strings. Okay, so strings can be, let us say, I can say char a. Anything can be there. I can write here anything. Say Sumit. This is a string. Okay, we can have some data types of pointer type. So pointer is a special type of data type which actually stores the address of a particular variable. So I can, how do I declare a pointer? So I can have a variable, let us say a is equal to 5. Okay, then I can write int star p is equal to ampersand a. Okay, so star p here is a pointer, ampersand shows the address. I guess all of you know, I'm just repeating a little bit. Okay, so like this, we are going to use the different data types and variables. Okay, we have various operators also. So operators, we have arithmetic operator, logical operator. Okay, we have various, what you call, the Boolean operator. We have also even shifting operator, bitwise operators. Okay, so bitwise operators are very important when we are using it the embedded C. Okay, let us say we have 32 bits. I want to just change the fifth bit. Okay, so for an example, I have, okay, I'll go to the other one. I have just one question to everyone. Okay, I have, let us say, int a is equal to uh, say 15. Okay, now what I want is 15 means, how can I write 15 is 1111. Okay, now I want to change this third bit from 1 to 0. So how can I do it? Can anyone tell me? How do I do it? This is a specific example of bitwise operator. Binary using not operator. But if you use not operator, all the bits will be changed. Yes, we can use AND operator. How do I use the AND operator? So if I AND here with 0 and all other value with 1, what is the bitwise AND of 1 and 1? This is 1. This is 1. This 1 and 0 is 0. And this is 1. Clear? So what I have to do is I have to write A. Okay. Then what I need to do? AND equal to. So if I am doing this 1011, so how I get this? So if I have 0100 and I do bitwise not, do you know this is bitwise not operator? So what is the answer? That is 101. So I can write and equal to bitwise not of A, or sorry, 0100 is, what is the value? 0100 is 4, no? Okay, so what this will happen is, so that means 1111, it will AND it with 0100. If I do negate or the bitwise not, it will be 1011. So the answer is 1101. I hope this is clear to everyone. So this is how, if you have 32-bit register, let us say 32-bit register, I want to change a particular bit to 0 or 1, that is to switch on a particular LED or switch off a particular LED, we can use this. So if I want to switch on or make a particular bit as 1, okay, so I want to make fifth bit as 1. Okay, so what I wrote this, and so here third value is, or 012. The second bit is 1. So instead of this, I can write it as 1 left shifted by 2. This is shifting operator. This is bitwise left shifting. This is bitwise right shifting. So if I want to make this fifth bit as 1, so what I will do, I can do OR equals to 1 left shifted by 5. So 1 is odd with any bit, the answer is 1. So this is how bitwise operator becomes very important. Okay, so similarly, control structure means you can have if else control structure, you can have for loop, while loop, different loops are there. Okay, we can be used. Okay, so ARM processor already we have discussed. The ARM architecture already we have discussed a little bit. It consumes with the write the code to give the power to on. That means what is the difference is, for all other microcontroller, always power is given. Okay, power for this only. So this power will writes that power has to be given. Otherwise, no power is given to the given a supply means always all the peripherals are getting the power. That is how it uses low power consumption. Scalability, you can take in this one, and same features you can manufacture multiple number of devices. Okay, so this is an STM32 microcontroller which I was telling. So STM32 means basically it is manufactured by ST Microelectronics, uses ARM based 32-bit microcontroller. Clear? Okay, so what are the things which I told? You can have communication protocols, you can have timers, you can have GPIOS, you can have clocks. Okay, so it has different timers. It has timer 0, timer 1, timer 2, like that. Multiple timers are there. Every timer has some registers. Accordingly, you can change the timers. And these timers mostly do the clocking system. Okay, and apart from that, ARM has its own timer, which is means there is also some separate timer by ARM. Okay, so they only work on the clocking system. Similarly, for communication interfaces, also we have different registers. For GPIOs also we have different registers. Okay, that later on someday we can work on the data sheet and the reference manual, and we can see. Okay, so this is what I was telling, the peripherals register. So the different peripherals. So now let us say we are working on a fan, we are working on camera, we are working on LED. So for all this, these are all connected to 11 GPIO pins. Okay, these GPIO pins are connected to different registers, and these registers are there in a form of memory. So like this memory is formed. So let us say this is 0x0000, 0x0001. Like that, we have different registers present in the memory. So this is called as memory mapping. So that means which register is present in which memory. So where do you see that? So the memory mapping, you can get it in the data sheet or the reference manual. Okay, we don't have much time now, so I'm not able to show that in more details to you. Okay, similarly we have this one, the digital pins, GPIOs. As already I have told you, you can use it for DACs or ADCs. We can use it for communication protocols, different things we can use it. Timers, as I told you, we can use it for timing, we can use it for delay calculation, we can use it for timers also, means counters also. Okay, interrupts are what? Interrupts, basically what happens, like in your Arduino programming, you would have always written a particular code like this, while one, then something inside that, this. So this is done by CPU, and this is always executing. So CPU cycles are wasted. Now if you don't want to waste CPU cycle, you have to use the interrupts. So what happens? Interrupts are basically hardware. What they do is, if some changes happen, then interrupts gets activated. So for interrupts, there is something called as interrupt service routines. Okay, so interrupt service routine addresses are mentioned in something called as vector table. So what you need to do is, you need to just activate that ISR. Okay, how do you do it? Using NVIC. We have an NVIC by the ARM. Okay, so basically what it does, NVIC, it is nested vectored interrupt controller. It sets the interrupt priority, and also it runs the interrupt service routine. Okay, then we have UART. So you have a device, you can just connect one wire from TX to RX. So that's it. If this is a transmitter, this is the receiver. So just connect TX to RX, and So now easily the data get transmitted. No clock pulse is required here. Very fast way of data transmission. Not very fast, but very reliable way of data transmission. Okay. So it has only a start bit, it has a stop bit, and then it has a parity bit to check if any error is there or not. Okay. We have three important things to do it on this. Whether you want it as an interrupt mode, like work on the interrupt service routine, or polling mode. Polling mode means it is working on, just a second. So in polling mode is what I told. Inside the while loop, you always check whether the data received or whether the data transmitted through UART. So you can have polling mode or you can have interrupt mode. Okay. Interrupt mode is controlled by hardware, by the controller. Polling mode is done by the CPU. So CPU cycles are wasted most of the time. So we prefer the interrupt mode. But easiest way of programming is polling mode. Okay. Frame format, whether it is a 7-bit data, 8-bit data, 9-bit data, what is the parity, all these things. Baud rate is what is the bits per second. Whether the standard is 9600 BPS, but we can have different varieties of baud rate. Okay. ADC, I told ADC is what we have an analog data, and if you get it to ADC, it will be changed into some digital data of 10-bit or 12-bit. So basically STM32 with ARM controller, it has or ARM processor, it has 12-bit ADC. So 12-bit means it is 2 to the power 12. That is 0 to 4096. Total 4096 values, which is converted from 0 to 4, because 1 to 4096 is 4096, but 0 to 4095. So it is changed to any digital data between 0 to 4095. So we have to read the data by ADC, and for that also we have some registers. We have a data register which will store the value of ADC. Okay. And based upon that, we can program or we can code it to work on some GPIO. Okay. DAC is exactly opposite. What it does is it takes the digital data of 12-bit and it converts it to some analog data, but not the specific analog data, stepwise analog data. Okay, I hope this is clear. Okay, so there are different configurations of ADC, DACs, which is available, which we can have on some other day.